Hello and welcome back to the Tech Blackboard. Once again today in our part 5, I have got 15 very latest and important questions for you in our AI-900 real exam question and answer series. And as always, please keep supporting me with your likes and subscriptions. If you have already done that, a big thanks to you. Just in case you are visiting the Tech Blackboard for the first time today, I need to mention that we have already covered 45 questions in AI-900 real exam question and answer series. And for each part, you can get a free PDF with all the questions and answers if you answer some simple questions asked in the respective parts. Please do not forget to watch the first part. That will make you understand overall AI-900 exam and why you should do AI-900. And of course, you want to strengthen your study by learning in offline mode. And for that, I will give you a PDF version for this part 5 with all the questions and answers if you tell me the correct answer for question number 46, question number 52 and question number 59. All the answers you will find in this very video. So let's begin. Let's start our part 5 with question number 46. The question says that you use an Azure Machine Learning Designer pipeline to train and test a binary classification model. You review the model's performance metrics in an evaluate model module and note that it has a AUC score of 0.3. What can you conclude about the model? And your options are: the model can explain 30% of the variance between true and predicted labels. The second one is the model predicts accurately for 70% of test cases. The third one is the model performs worse than the random guessing. Now, before I tell you the correct answer, let me give you a one-liner on what is AUC. So AUC stands for area under the curve. This graph represents the probability that a random positive example is positioned to the right of a random negative example. Now coming to the correct answer for this question is option C, the model performs worse than a random guessing. So here I present a quick scale or a benchmark that you can use whenever there are questions on AUC score. And it shows that if you have a score of 0.5, then you are as good as a random choice. However, our score was 0.3, which is of course less than 0.5, and that's why our model performs worse than the random guessing. Similarly, if your score is between 0.5 to 0.7, then you are poor performance. And then the score between 0.7 and 0.8 reflects that you are at okay performance. And finally, a score between 0.8 to 0.9 represents that you have a very good performance. I strongly recommend that you take a screenshot of this scale here so that you can use this scale whenever you are sitting in the exam. I don't mean that you copy this scale in the exam, but I want you to learn this scale. Now coming to question number 47. The question says that you use Azure Machine Learning Designer to create a training pipeline for a classification model. What must you do before deploying the model as a service? Your options are: create an inference pipeline from the training pipeline, or should you add an evaluate model module to the training pipeline, or the third option is clone the training pipeline with a different name. The correct answer for this question is option A, create an inference pipeline from the training pipeline. Our question number 48 says that you are using Azure Machine Learning Designer to create a training pipeline for a binary classification model. You have added dataset containing features and labels, a two-class decision forest module, and a train model module. You plan to use score model and evaluate models to test the train model with a subset of dataset that wasn't used for training. What's the another module should you add? Your options are join data, split data, select column in dataset. The correct answer for this question is option B, split data. The reason is that you should always use split data module to randomly split dataset into test and validation subsets. Moving on, we have question number 49. It says that the ability to extract subtotals and totals from a receipt is a capability of the custom vision, form recognizer, ink recognizer, or text analytics. The correct answer for this question is option B, form recognizer. And just to get you started with Azure Form Recognizer, this is the documentation. And you can read here that to accelerate your business processes by automating information extraction, Form Recognizer applies advanced machine learning to accurately extract text, key value pairs, tables, and structures from the document. Further, it says that with just a few samples, tailor the Form Recognizer to understand your documents both on-premise and in cloud. Turn the document into usable data at a fraction of the time and cost to focus more on acting on the information rather than compiling it. And that's exactly what our question demanded as well. The question wanted us to extract subtotals and totals from a receipt. That's why we chose Form Recognizer as an answer to this question. Let's move on with question number 50, and here we have a yes-no kind of question. Let's read the first statement. It says that Azure Machine Learning Designer provides a drag and drop visual canvas to build, test, and deploy machine learning models. And the correct answer for this statement is yes. And the reason is that Azure Machine Learning Designer lets you visually connect datasets and modules on an interactive canvas to create machine learning models. Moving on with the second statement, it says Azure Machine Learning Designer enables you to save your progress as a pipeline draft. The correct answer for this statement is yes. Very surely with Azure Machine Learning Designer, you can connect the modules to create a pipeline draft. And that's why this is a yes statement. Moving on with statement C, we have Azure Machine Learning Designer enables you to include custom JavaScript function. And the correct answer for this statement is no. Coming to a very interesting question, question number 51. The question says that you have the following data set. So you can see here you have household income, you have postal code, and then you have house price category. You can see the values of each column here. Moving on, the question says that you plan to use the data set to train a model that will predict the house price categories for the houses. And here, please pay attention. The prediction that our model needs to do is house price categories. Moving on, the question asks what are household income and household price category? To answer, select the appropriate option in the answer area. Each correct selection is worth 1 point. So here you can see the question is asking whether the household income is a feature or a label. Similarly, whether the house price category is a feature or a label. Now let me show you the answer and then I will give you a detailed explanation for this. So the correct category of household income is feature. So household income is a feature. On the other hand, house price category is a label. Now let me give you a detailed explanation what is a feature and what is a label. So here you can see I have defined and given you an example how you can recognize the label. So label is essentially the possible class. So let's understand the difference between labels and feature using an example. So you can say the possible classes of animals can be cats or birds. You can categorize animals on different factors. For example, they can be carnivorous, herbivorous, or omnivorous, or there can be many other classes for animals. However, for this example, I have taken cats or birds. Now, in this case, the label would be the possible class association like cats or bird that your machine learning algorithm will predict. So essentially labels are nothing, they are just the output or the actual prediction that your model will do. Moving on with the features, so features are what? Features are patterns. So we took the example of animals like cats and birds. So features in this case would be pattern or colors or forms that are part of your class. What was our class? Our class was cats or birds. So what will be the features? Features could be something like fur or the feathers or maybe their colors or sizes or other low level interpretation like pixel values. So essentially what are features then? So features are attributes or properties of your class. Now coming back to our question slide, let's try to associate the concepts that we just learned in the question. So here you can see we have household income. So what is a household income? As we saw here in the answer, household income is categorized as a feature. Why? Because it is like a property or an attribute to a household. That's why it is categorized as a feature. On the other hand, house price category. Now once again I will repeat and you need to focus that house price categories is something that our model needs to predict, and that's why it is categorized as a label. I will once again summarize. Labels are predictions or the actual output of your model, whereas features are nothing but the properties or attributes of your classes. I hope this makes it simple to understand, but in case you have any doubts, questions, do ask me in the comment section. Coming to question number 52, the question says that you are building a tool that will process images from retail stores and identify the products of competitors. The solution will use a custom model. Which Azure cognitive service should you use? Your options are custom vision, form recognizer, face, or computer vision. The correct answer for this question is option A, custom vision. Now let's jump to the question number 53. And the question says that you plan to use the custom vision service to train an image classification model. You want to create a resource that can only be used for model training and not for prediction. Which kind of resource should you create in your Azure subscription? Your options are custom vision, cognitive services, or computer vision. The correct answer for this question is option A, custom vision. So here in this box that appears now, you can see option A, custom vision is correct, because when you create a custom vision resource, you can specify whether it is to be used for training, prediction, or both. And that's why custom vision fits this question. Moving on with cognitive service resource can be used by custom vision service for both training and prediction. So basically, when you're using cognitive service, you cannot specify that whether it is to be used for training or prediction or both. It has to be used by both training and prediction. Then we have computer vision, and in this case, the computer vision service does not support the training of custom image classification model, and that's why it doesn't fit this question. Coming to the question number 54, and that says that when you design an AI system to assess whether loan should be approved, the factors used to make decisions should be explainable. This is an example of which Microsoft guiding principle for responsible AI. Your options are transparency, inclusiveness, fairness, privacy, and security. And the correct answer for this question is option A, transparency. Now let me give you a little bit more detail on transparency. So achieving transparency helps the team to understand the data and algorithms used to train the model, what transformation logic was applied to the data, the final model that was generated, and its associated assets. This information offers insights about how the model was created, which allows it to be reproduced in a transparent way. And that's why transparency is the option that fits this question well. In case you want to read more on the other principles of responsible AI, then this is the Microsoft documentation. And here on this page, you can read all the 6 principles for responsible AI, which are accountability, inclusiveness, reliability, and safety. Then we have fairness, transparency, and last but not the least, privacy and security. It's well elaborated page. You will understand a lot, and in one sense this is a very important page as well, because a lot of question in AI 900 are coming around these 6 key principles for responsible AI. The link for this page and all the other documents that I'm using in this video are available in the description box. Moving on with question number 55. Before I read this question, friends, it's my humble request that if you're liking the content so far, then please press that like button. Your each like boosts my confidence. It encourages me to do all these hard work in collecting the latest questions and finding supporting Microsoft documentation. So please support me by pressing that like button. Now let's read the question. The question says that what information must you provide to developers who want to use image classification model? Your options are, should you only provide project ID? Or the option B is that along with the project ID, you also provide the model name and the key and the endpoint for the prediction resource. And the option C says that with project ID, you also provide the iteration number and the key and the endpoint for the training resource. The correct answer for this question is option B, that you should provide project ID, the model name, and the key and the endpoint for the prediction resource. Now let me give you a little explanation of each option. So option A, which said that we should only provide the project ID, is an incorrect option. The reason is that project ID on its own is not enough information to use the published model. On the other hand, the option B we saw is a correct option. Why? Because to use publish model, you need to provide project ID, model name, and key and the endpoints for the prediction resource. The third option is also incorrect. The reason is that you need to provide model name rather than the iteration number. And also understand the key and endpoint must be for the prediction resource and not for the training resource. And that's why option C is an incorrect option. Moving on with question number 56, and it says that you are designing an AI system that empowers everyone, including people who have hearing, visual, and other impairments. This is an example of which Microsoft guiding principle for responsible AI. The options are transparency, inclusiveness, fairness, privacy, and security. The correct answer for this question is option B, inclusiveness. And the reason is that we want to include everyone, as mentioned in the question, that the AI system empowers everyone and it also includes the people who have hearing or visual or any other kind of impairments. That's why inclusiveness is the correct answer. Now let's read question number 57. The question says that you run a charity event that involves posting photos of people wearing sunglasses on Twitter. You need to ensure that you only retweet photos that meet the following requirements. The first requirement is include one or more faces, and the second one is contain at least one person wearing sunglasses. What should you do to analyze the image? Should you use the verify operation in face service or should you use the detect operation in face service? The third option is should you use the describe image operation in the computer vision service? And the last option is the analyze image operation in the computer vision service. And the correct answer for this question is option B. You should use the detect operation in the face service. Let's check out our question number 58. The question says the handling of unusual or missing values provided to an AI system is a consideration for which of the following Microsoft principle for responsible AI. The options are listed here. The first one is transparency, inclusiveness, fairness, privacy and security, or the last one is reliability and safety. The correct answer for this question is option E, reliability and safety. And here comes question number 59. The question says that you train an image classification model that achieves less than satisfactory evaluation metrics. How might you improve it? Your options are should you reduce the size of the images used to train the model or should you add a new label for unknown classes? And the last option is should you add more images to training set? And the correct answer for this question is you should always add more images to the training set. Just to give you a little more detail, here is the reasoning for all of the options given here. The option A, which is an incorrect option, the reason is that changing the size of images is unlikely to improve performance significantly and reducing them may even lose some resolution and make model worse. That's why the option A is an incorrect option. Then moving on, the option B, which asked us to add a new label for the unknown class. This is also an incorrect option. The reason is that adding an unknown label will not improve the accuracy of the predictions for the classes you want to identify. That's why this is an incorrect option. And the reason for option C as a correct option is that generally adding more images to the project and retraining the model is likely to improve the performance. And that makes option C as a correct option. And now on your screen is question number 60, which is the last question for our part 5 in our AI-900 real exam question and answer series. This again is a statement based question and you have to tell whether the statement is yes or whether it's a no. Let's read the first statement. The first statement says, forecasting housing prices based on historical data is an example of anomaly detection. The correct answer for this statement is no. And then comes our statement B, which says that identifying suspicious sign-ins by looking the deviation from usual patterns is an example of anomaly detection. And of course, this is a correct statement. So the answer is yes. Moving on with the statement 3, it says that predicting whether a patient will develop diabetes based on the patient's medical history is an example of anomaly detection. This is a no, and the reason is that you are trying to predict whether a patient will develop the diabetes based on its medical history. So primarily it's a prediction and not an anomaly detection. And these were our 15 questions in part 5 of AI 900 exam series. I'm hopeful that you liked the questions and answers, and the Microsoft documentation that I presented will surely help you a long way in your AI 900 examination. And please do not forget to like the video and subscribe to the channel, and also press that notification bell so that you get notification of all our upcoming exam series. Till we meet again in our next video, stay fit, keep learning, and thanks for watching.
If this video has added any value in your learning, a like and subscribe is highly appreciated. Share this video in your family and friends to spread and expand their learning. Your comments and feedback give me a chance to interact with you, and I look forward for them. We will meet again in our next video. Till then, stay fit, keep learning, and thanks for watching.